I want to poke a little bit deeper into more on Solidity contracts and also take a look at a little bit deeper into how the protocol works and how you talk to an Ethereum server. The first thing is we have a blockchain, and one of those things you can do with a blockchain is you can get a receipt for running a transaction. And when you create some sort of a transaction, you try and transfer 25 Ethereum from Bob to Jane. The end result of this is a transaction, and you get a receipt ID for that transaction. You can actually get back that entire transaction, which means that if there were events generated, you can pull back those events and see what they are and verify that those events exist. Now, this is not generally how you test stuff, but let's say that I set up a contract that is tracking the number of shares. This is one of the first bills that was implemented, was to track the number of shares in a company, and here in the state of Wyoming. So you've set up your corporate governance to track the shares, and each time you transfer a share from one person to another, it gets recorded on the blockchain. That's how the transfer takes place. This is much more real time than what happens in the real stock market, where it takes 2 days for shares to clear. This can happen in 20 or 30 seconds to clear the shares. So there's lots of reasons for doing this. But at the end of this, every year you have to do a report on who owns the shares to the Security and Exchange Commission. Now, usually what happens is about a month before that report takes place, a person in the business department goes and they start trying to figure out who owns the shares. And in the month that they're trying to figure it out, of course, the ownership of the shares changes. And so this is a really difficult, time-consuming, horrible process. If you've got them on a blockchain, you simply go to something like the Blockchain Explorer and you say, list out all the events on this particular contract that holds the shares, and list the transfer events. And at the end of that, you just add up the numbers and say, well, this person bought 400 and sold 200, therefore they have 200 left, and this other person bought 200. But you just add up those events. The way that it goes about getting those events is I've put in a little tiny script here that it's going to do this a whole bunch of times, usually through something like Blockchain Explorer, but this tiny little script will give you the results of an individual transaction. And Ethereum makes things more easy than just reading all the transactions, but at some level you're going to have to pull back the transaction itself to find the actual details of the event. You can search for events using their system, but eventually you get down to this. Let's take a look at this specifically. curl is a tool for accessing websites, see URL, and it allows you to do something like specify this header, which we need a content of application JSON because that's what we're sending down here. So we're sending it a little JSON script. Normally, if you do curl, it will do a get, but what we want to do is a post request. That's what the protocol requires. And the data we send is this piece of JSON that if you actually do it, you kind of need to put it on one line. But I have split it up so we can actually read it here. And it says that the thing that I'm after is JSON RPC version 2. If you send one to this system, it'll just reject it as an invalid version. But it needs version 2. And the method that you're calling is this function getETH transaction receipt. There's another way to do this, but if you're not sitting on the computer running the Geth Ethereum server, this is how you have to do it, is by a remote procedure call. The parameters to this remote procedure call are an array of values, and it only takes one value in this array. And this array is the hexadecimal transaction hash. So it's the actual hash, the seal, or the receipt seal for that block or that transaction. So there is that, and then there is this mystery ID that you probably want to set to 1. Now, when you make a request to a Geth server, these requests get queued up inside the server. They don't get run immediately. And if before it is run, okay, you decide, oh, I'd really like to replace that one, you can send the same request again, and you could say ID2, and you could replace your existing request with a new request. So this ID that you're using here counts up and it is the nonce. If you send another request that is the same with the same ID, then it will just throw away the new request because it's a duplicate. And it'll only run one copy at a time per block. Now that's one per requesting account. Now the last piece of this, and this is one that if we're going to actually run it today, we're going to have to change, is the address. And in this case, I'm sending it off to this server at this IP address at port 8545, which would be a Geth server. Now, if we run this with the Ganache CLI testing server on our local system, we probably first of all want the IP address to be localhost. So you'd change it from 192 to 127.0.0.1. And by default, Ganache runs at 9545 instead of 8545. If you're trying to access the internal testing server in Truffle, again, you'd want localhost, which is 127.0.0.1. And its default is 7545. So you might have to tweak this a little bit, but this basically is a script that you can use to pull back a JSON response on what is in a transaction. And part of the information in a transaction is the events that are generated from that transaction. Now, another thing that you'd be interested in would be to find out for a specific account what the balance in that account is. And again, we've covered some of this, but we have this eth_get_balance. And this eth_get_balance tells us for an account how much it has. And it has two parameters. You see there's the square bracket here and here to indicate these are the parameters. I'm using the same ID equals 1 nonce. And what I send to it is an account number. And I say the account what I want is not in a specific block. The block number is latest. So it's the most recent for that account summed up. So we can go out and find out for any account in Ethereum or any contract that we know what the account is that holds that contract, what is the balance on that account. And again, it has the IP address to send it to, which you'd have to tweak. But that's a good way to find out for that particular account. Like, does it have funds to do this? Or did I try to make a call to some method that is owned by this account and I got back, some unexpected result? One of the first questions I'd ask is, does that account have enough gas to pay for running the contract? So getting the account balance is a pretty critical thing.